We're now going to start question 4, which is an indices question. So let's start with A. We've got the curve y equals 4 to the x, and we get asked to sketch that on a coordinate axis. So let's get ourselves some axes here. So 4 to the power of x. Now, we know that if we make x 0, then we're going to get y equals 4 to the power of 0. Anything to the power of 0 equals 1. So we know that we're going to be crossing at the point 1 in there, little 1. So we're going to be crossing at point 1 there. And then as x gets bigger, then y is going to get bigger at a bigger rate, because you're going to the power of 2, to the power of 3, to the power of 4. It's going to get bigger and bigger and bigger. So let's draw that out like this. Let me do that again, that wasn't very smooth. So something like this. So it's going to get bigger, it's going to go increasing at an increasing rate. I should put my little x and y in there. Let's do that now. So x and y in there. Now on the negative side, negative x, then when you get 4 to the power of minus 2, minus 5, minus 50, it doesn't drop below 0. It'll just get smaller. So y to the power of, not y to the power of, 4 to the power of 500,000 is going to be 0.000 something 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 3 or 5 or whatever. So it's going to be 0. It's going to be close to 0, but it's not going to be 0. So this, when it comes down, is going to be close to 0, but never actually touching 0. Never touching 0. So that's how we draw that. The mark scheme wants you to say that this point here, this point over here, is the point 0, 1, brackets, 0, 1. It wants this to be an asymptote, which means it never touches 0, and it wants this to be increasing at an increasing rate, which that is. So that's for A. Let's move on to our next question, question B. Next question. So let's have a look. Describe the geometrical transformation. So easy. Geometrical transformation that goes from y equals 4x, 4 to the power of x, to y equals 4 to the power of x minus 5. So that minus 5 there doesn't affect the x, it affects the y. Okay, it's not inside the x. If it was 4 to the power of 5x, then it would be changing the x, but it's not. It's changing the y. So we have a translation. Translation. 1 mark. And we are going to move. We're going to move this whole shape. We're going to move it 0 in the x direction, because it's not affecting the x. 0 in the x direction. And then it's going down 5, because you've got minus 5 in the y direction. So it's going to go down 5 places. So minus 5. 2 marks. Couldn't be easier, I don't think. So let's get rid of that again. Good. So question C, part I, part 1. Use the substitution. Okay, so we've got an equation here. This is our equation, and we have to make it look like the one underlined in purple. We've got to make it look like that using this substitution. So let's write both of those out. I think this will make it easier. Let's go down a little bit. So we have our two equations. We've got 4 to the power of x minus 2 to the power of x plus 2 minus 5 equals 0. Equal to 0. And our second one, which is y squared minus 4y minus 5 is equal to 0. So we have to make this the same as this, this the same as this, this the same as this, and this the same as this. They all just translate down. So let's start with the first one. We've got 4 to the power of x is going to be y squared. Let me write down our little substitution as well. Right, we've got y is equal to 2 to the power of x. That's what y is equal to. So let's get started then. Let's start with this first term here. So we've got to make 4 to the power of x. 4 to the power of x. So we'll start with that, and we're aiming for y squared. So 4 to the power of x. Let's try and break this up. We're aiming for this. We're aiming for this one squared. So 2 to the power of x squared. So you can do it either way around. You can work from 2 to the x squared back to try and get to 4 to the power of x, or you can go kind of forwards. So I've gone backwards in the answers on the website, so I'm going to go forwards on here. So 4 to the x can then be changed into 2 to the power of 2 x to the power of x. So I've changed 4 into 2 squared, which we know it is. So then what we can do is say that, okay, indices rule, we've got 2 here to the power of x. So what do you do when you've got an indice to the power of? You times them together. So you can go 2 to the power of 2x. And then in just the same way that we did that, we can go back the other way and say we've got 2 to the power of x all squared. So we've just swapped, if we go here, we've swapped these two around here. We've just swapped those two around, which we can do with our indices rules. Okay, and then what we can do there is say that, go down a bit, we can say that 2 to the power of x all squared is equal to y squared, because y is 2 to the power of x. So that's just a direct, here we go, look, here we go. Y is 2 to the power of x, so we've squared it all. So that's the first bit taken care of. Let's do the second bit. Then this question's done. So we have 2 to the power of x plus 2 goes to 4y. So 2 to the power of 2 plus x, or x plus 2, doesn't make any difference. Get rid of that. So what can we do with that? Well, 2 to the power of 2 plus x. So indices rule again, this is an indices question. That is equal to 2 to the power of 2 times by 2 to the power of x. That's a basic indices thing. So we just split that down the middle there and said 2 squared and 2 to the power of x times together. So, well, we can simplify that. We can make that a 4 times by 2 to the power of x. And hey, there we go again. 2 to the power of x is going to be y. 4 stays the same. So let's go here. 4 stays the same. 4y. That's what we were going for. We've gone from 2 to the power of x plus 2 down into 4y. We've done it. So let's say that we've done that. We've done it. Therefore, here we are. Therefore, 4 to the power of x minus 2 to the power of x plus 2 minus 5 equals 0 can be written as y squared minus 4y minus 5 equals 0. That is what you do to get the 2 marks there. It's quite a long question, quite difficult in some parts, but not too bad if you know your indices rules. So the next one, I'm going to leave that there. You'll see why in a minute. I'll leave that there. So hence show. So use what you did before to show that this equation that we just dealt with has only one real solution, and then find the solution go to 3 decimal places. So let's do that. So I might run out of space here, but hopefully not. So we have, let's go down a bit. So we have y squared minus 4y minus 5. That is the same as the equation in the question. We just proved that it's exactly the same. So with this we can get a y equals. So we can go, here we can go y minus 5, y plus 1 is equal to 0, and then we get y is equal to 5, and y is equal to minus 1. So you've all done that before 100 times. So let's say what that means then. That means that 2 to the power of x is equal to 5. And it means that 2 to the power of x is equal to minus 1. But if we go up here, if we go back to our original sketch up here, we go to this, we know that how can 2 to the power of x, this is what we just said, 2 to the power of x equals minus 1. How can it be equal to minus 1? It never goes below the x-axis. It never goes, so y can never be minus 1. So that's not a real solution, so we need to write that down. It is not a real solution because 2 to the x is always greater than 0. Therefore, the 3 dots, therefore 2 to the x equal to 5 is the only solution. There. So let's work out what that is then, using logs. It says use logs. Let's use logs. So we have that there. So minus 1, not a solution. Get rid of that. So let's log both sides. Log 2 to the power of x equals log 5. So normally, or sometimes, you have a little number here, a little base number there. It doesn't matter what that is in this case, because we're not dealing with different logs with different bases on different sides, so let's ignore that for now. We don't need that. Right, now, log laws. What we can do is take this x, this indice here, and bring it around the front. Logs allow us to do that. So we have x log 2 is equal to the log of 5. Log 5 hasn't changed. Then we can divide both sides by log 2. Divide both sides by log 2. I'm going to come up here for space. So we can say that x is equal to log 2 over log 5. Or 2 over log 5. And then you put that into your calculator, and you are going to get x is equal to, remember, 3 decimal places. 3 decimal places. So you're going to get 2.322 to 3 decimal places. And that is our answer. We have done question 4. I'll see you on the next video.